Hiya guys, BuildZoid here, and it's time to be disappointed again, more so than last time. Remember how Gigabyte lied about how many phases their boards have? Well, Asrock will lie to you about which PWM vendor they freaking use. Like, an all-time low. It's never been worse. This is it. Okay, so let's just scroll through this is the X470 Master SLI. I've just gotten my hands on the board. It just came in from Scan, so I had to go buy it because, quite frankly, if I ask Asrock, hey, could you send me your board so I can tell everybody how it doesn't have as many phases as you're saying it has, and then rip on you for actually lying about who makes the freaking voltage controller, I'd probably never get it, would I? So anyway, let's scroll down through this lovely product page and see what Asrock thinks their VRM is made of. So it's a digital power IR digital PWM, 12 power phase design, and it uses a premium 45 amp choke. The only one of those statements that I consider not a lie is that 45 amp choke. And I do still find that a really bad engineering decision because the chokes on this motherboard are 500 nanohenry. Buying a 500 nanohenry 45 amp choke twice is almost certainly more expensive than just buying one 60 amp choke that's rated for 250 nanohenries, because in order to achieve the higher inductance, you generally need more coils of wire, and more coils of wire generally mean higher direct current resistance, which means less current handling capability. So if you ever look at some of the really high current, if you look at most choke manufacturers, if you just look through the list of chokes they make, you will notice that if you go from like 150 nanohenry to a 300 nanohenry choke within the same product family, the trade-off you do for getting that higher inductance is that you lose current capability, right? And this is a 500 nanohenry choke rated for 45 amps. Which there's two of them in each phase, so you have like, I don't know, what, 90 times 4, that's 360 amps worth of choke, which is completely ridiculous because this VRM is never ever going to pass 360 amps without catching fire. But that's fine, you know, we totally need 8 45 amp chokes, because just using 4 60 amp chokes wouldn't look quite as good on our lovely marketing page. So, okay, but the bigger issue I have here is the 12 power phase design, because they don't have that, and the IR digital PWM, which is, here's the thing. When I first looked at this motherboard page, and I saw that they're advertising a 12 power phase design, and then the IR digital PWM, I was like, hey, this might not suck so much. This might be the only cheap X470 motherboard on Earth with an actual 8 phase for its V-Core VRM. Oh, how wrong I was. I am sorry I ever trusted you, Asrock, but then again, I shouldn't be surprised at this point. So here's another motherboard, just so that we can compare that this is consistent within their marketing department. So DigiPower IR Digital PWM. And I know for a fact that this motherboard uses an international rectifier 35201, which is, like, that's an international rectifier part. So anybody want to have a guess at what this thing uses? Oh, I don't know. Let's skip over to here. So here we have the Master SLI, but we've already taken the heatsinks off, and also, if you're wondering about that bandage, it's because of this heatsink right here. Turns out that the way they've cut this right here, they've actually left that really like razor sharp, so I cut myself on that. And, you know, that's not a big deal. It's just like, yeah, the motherboard bites. I guess it's scared of me. So here we go. Can anybody guess whose actual voltage controller this board uses for its V-Core VRM? Oh, I don't know. That sure doesn't look like an IR35201 to me. Wait, let's get that bright spot out of there. Oh. Come on, focus, you stupid camera. Oh, I don't know, that looks like an ISL 95712! I wonder since when International Rectifier rebranded themselves to Intersil. I really do, because I've not heard about this takeover by Intersil of International Rectifier. I don't know, Asrock, you know, like, I'm pretty sure your website says that that's an International Rectifier Digital PWM, which, at least for this motherboard, means that it uses an IR35201, which is an international rectifier part. But this board uses an ISL 95712. And you know, initially I was like, you know, maybe Asrock, what they're doing is that's an ISL chip, but there's an international rectifier somewhere else on this motherboard. But that's not actually the case, because that there for the memory power is a rich tech, okay? And down in this area, I mean, actually down in this area there might be something from international rectifier. These are all really low power parts though, so it's just like, I wouldn't count that. But that's another rich tech down there. Except that's a single phase rich tech controller, so that would need a controller of some kind. And I can't see it, so I don't know what's up with that one. But, yeah. The VCore VRM on this definitely is not made with a digital international rectifier voltage controller. It's made with an ISL 95712, which automatically means that this VRM also can't have 12 phases in total, because that chip is a 4+3 at best. So let's check out how the gates on these MOSFETs are set up. Oh wait, these are Nyko semiconductors, so that's going to be a pain to find in a data sheet. But hey, you know what's better than your cheap voltage controller that you lied about? When you use MOSFETs from Nyko Semiconductor, my favorite firecracker supplier. Let's see. There we go. That says Nyko Semiconductor. Those are Nyko FETs. And actually, you can kind of see it better on the memory VRM there. That's a Nyko. N-I-K-O-S on that MOSFET. And that's the same thing they have in the VCore VRM. You know why why I rip on MSI for using Nyko Semiconductor MOSFETs? Because they suck. And MSI, so far, all the X470 motherboards I've had from MSI are used, like on X370 and B350, MSI was smacking this kind of Nyko part just about everywhere. And I was like, okay, so that's terrible. Because MSI was putting these Nyko parts onto motherboards that cost like $250 or even $300, and it's just like, that's just ripping everybody off, because these FETs are, like, as far as I'm aware, this is literally the cheapest MOSFETs you can get your hands on. The manufacturer's website definitely reflects that. Like, don't go there, that's a nightmare. So MSI upgraded to all on semiconductor MOSFETs, but hey, here's Asrock. They're on the Nyko semiconductor train. So, yeah, that's great, isn't it? Let's see how and actually I'll show you how else we can tell that this is a 4+2 phase, not a 12 phase. Is if we look at the back here, right? Come on, focus. You can see that so that's the high voltage side of the choke, right? That there. And you can see that trace connecting the two. You know why they do that? Because otherwise your current sensing wouldn't work. Otherwise your power balancing between the 4 phases wouldn't work. You need to tie the chokes together like that so that they look like one phase, at least to the voltage controller. So that right there, that's just more proof that this is not an actual 12 phase. But let's see if I can get the gates on these. So, luckily Asrock left a whole bunch of unoccupied capacitor pads right there, which look like they would have been for VCore, so we should be able to trace through the do a resistance check through the inductors, which should tell us everything we need to know about which leg is the gate. So first we're going to go find a ground, so I'm just going to go against that. Okay, that's ground, because that's 160. This new meter, this is a Keysight U1272A. It goes into the milliohm range, so don't be fooled. That there is ground, because that's 0.15. That's 150 milliohms, which makes sense because I'm just measuring off of the casing of a USB port. That doesn't need to be hooked into the ground plane particularly well, but there we go, that's VCore. And we know that's VCore because we have a lot of resistance there and there's not currently a CPU installed. So if we measure from that to, normally that would be like here. Yeah, so you can see that's just shorted to the MOSFET there, as well as that leg. as well as that leg. So that means this one should be the gate. This one's probably the gate. Yeah, so we can see that's the gate. That's the gate of the MOSFET. And with all probability, that's going to be tied to this leg as well. Is it? Don't make me look like an idiot. Oh, yeah, it is. Okay, so, oh, you can't actually see the measurement I'm making. Basically, what I was measuring right there was, if you come down close, right, so I was measuring from this leg. Come on, focus. Focus, idiot. Come on, you. Come on, camera. You can do it. I believe in you. There. Okay. So I was basically measuring from this leg right here, right, to this one right there. And those are shorted together. And that's the gate of each of these MOSFETs. Well, I assume that's the gate of each of these MOSFETs. I've not yet checked the data sheet, but I can't think of much else those could be, right? If we go across like, so you can see I'm doing that one, and then I'm doing this one. And yeah, they're shorted together. So the gates are tied together. That's lovely. And keep in mind that the hundreds of like that 100 milliohms you're seeing, that's more due to contact resistance than actual resistance. Also, I've not compensated the meter for probe resistance. So not right now. Like we could, but it's not useful because we're like this thing's not accurate in the 1 milliohm range at all. Like that last digit of the milliohm measurement is useless. But basically, you can clearly see here, so they're tying the gates together. They're not actually tying the switch side fully together, as far as I can tell, which is fine, because, like, if you actually do that, then it kind of, like, this, well, if you do what Gigabyte did, then you can, like, put the high-side MOSFET on and off whenever you feel like. But if you do what Asrock has here, then you can't actually remove the high-side MOSFET because there's no proper big power, like there's no power trace connecting this inductor to that inductor. But they're still, like, from the perspective of the voltage controller, these two are that's one phase right there. I've just covered up one phase. This would be half a phase. That's one phase. Because that's how the controller sees it. Also, what I find really interesting is they stuck the two driver MOSFETs down here, which I'm not sure, like, that's just an interesting design decision right there, because they have the two drivers down here, which just, like, so they're driving that and that off of those two, which just, normally you want the drivers to be as close to the MOSFETs as possible to not have a long rise time, but, and that's not as close as possible, okay? Like, there are, like, a lot of high-end GPUs, what they'll do is they'll have, like, they'll have the driver literally on the opposite side of the board. So like on the side of the MOSFETs, if you flip the board over, right on the opposite side, you'll actually find the driver, so that it's as close to the MOSFETs as possible, or like really, really close. But that's not as close as possible. But that's fine. That probably doesn't make a huge difference to the performance of this. The main problem here is that's not an international rectifier voltage controller. This is not a 12-phase, and those are Nyko semiconductor MOSFETs. Asrock, you suck. Especially because you have the audacity to say this is an international rectifier digital PWM. Like, here's the thing, the 12 power phase design, calling this a 12-phase, that is completely normal for this entire industry. But, except maybe Asus. I'm not aware of Asus having done this. I know Gigabyte's done this, MSI's done this in the past. Actually, somebody in the comments of the last video ripping on Gigabyte pointed out that if you actually scroll through MSI's product page long enough, you'll eventually find them saying that their motherboard has 11 power phases, which they counted 1 phase for memory power, 2 phases for the 2 phases which they do actually have for the SoC, and then they have their not 8 phases for the V-Core, which is actually, that's a 4-phase on those boards. So on the Gaming Plus, and I just managed to miss that. But here Asrock is like, yeah, we have a 12-phase, and they're advertising an international rectifier digital PWM. And you just know that they're doing that because maybe, just maybe, people are starting to wise up to the fact that, hey, you can't make a 4-phase ISL 95712 into a 8-phase, 4 plus 3 phase. You can't convert this chip into an 8 plus 4. It's literally impossible. That chip does not support that. The only way you could do that, if you wanted to do that, you would have to take the 2 drive signals that this chip has for phase 1 and 2 of the V-Core VRM. You'd have to convert those back into PWM signals, which is like the most stupid thing you're ever gonna do, and then put doublers on that. That's the only way that chip could ever support 8 phases. Nobody's gonna do that because that will be way too damn expensive to do, and at that point it's just cheaper to upgrade to a proper voltage controller. Also, somebody on the last video asked, like, how much more does a proper 8-phase cost versus this, which I should have the board up here, versus this sketchy doubling scheme. Well, it's not even a doubling scheme because there's no doublers. This is a fun, like that. Apparently the justification some board vendors have for this is because we've doubled how many components are in each phase. That's a doubling scheme. Here's the thing. That's not a doubling scheme, because a doubler is called a doubler because that actually doubles how many phases of the PWM signal you have. This is making one very fat phase. And incidentally, if you've ever looked at some GPUs, like for example a GTX 1070 reference card has a 4-phase VRM that's more powerful than, well, maybe not more powerful, but definitely more efficient than most of the fake 8-phase VRMs you see on, the 4 phases that you see on like X470 motherboards of this price point. But, so this is just, yeah, lies. Because you can functionally replace this 8-phase with a 4-phase of just literally twice the ratings of every component in there. This is not a doubling scheme. This is copy-pasting your MOSFETs. It's a 4-phase. Also, that's an intersil, which is just like, oh, and I wanted to address like the cost difference. So the cost difference for going from an ISL 95712 to an actual international rectifier voltage controller, especially like an 8-phase, is actually really high. Because you would not only end up like, let's say you just use the IR35201, because that's the only chip I'm currently aware of that is both 8 phases and compatible with the AMD standard for V-Core on the Ryzen platforms. There's definitely other chips out there which support the standard. That's just the only one I'm aware of that's popularly used by various motherboard manufacturers. That thing does support an 8-phase output, but it's not an 8 plus 2 or an 8 plus 3, so then you have a problem because your SoC VRM doesn't have phases, right? So what you need to do, you'd have to buy the 35201, which is actually cheaper than the ISL 95712, except then you'd also have to buy 8 driver chips. Right, because the ISL, this has 2 drivers integrated, and then you only need 2 more drivers to get your total of 4 phases, because there's 4 drivers in total on here. Now, if you upgraded to the 35201, like Asrock is claiming they have done here, you'd need 8 drivers, which massively increases, like that's a big cost increase because driver chips are not that cheap, especially if you buy proper ones. So you'd end up spending extra money on driver chips, literally 4 times as much, because there's only 2 drivers on this thing versus you'd have to buy 8 for the 35201. And then you'd still be stuck in the situation of, hey, I don't actually have an SoC VRM. So then you'd have to go buy another voltage controller, which would either be like a 3, 4, or maybe another 35201. I'm not really sure what they would decide to go for there, but you'd have to buy another voltage controller and maybe another set of drivers for your SoC VRM. And at that point, that gets really expensive, right? Because so that would be really, really expensive. Now, the other way you could do it without using a second voltage controller and just using one international rectifier 35201 is you would take the 35201, you would take 4 phases off of the 35201, you would double those using something like an international rectifier 3599, and then you would have to buy drivers anyway, or you could use an international rectifier 3598, which integrates the drivers and the doubling scheme. So that would be another way to get an 8-phase. It wouldn't be a true 8-phase because the 3598 and the 3599 both, as far as I know, don't do proper current balancing, and they don't do proper current balance, which basically means that if the phases start coming out of balance, they're just going to keep running out of balance for as long as whatever, which is detrimental to the lifespan of the phases, but it's not it's not a huge problem. It's like still closer to being a real 8-phase than this. Okay, because this literally doesn't have this couldn't go out of balance on every 8 phase, like it couldn't have 1 phase out of 7 running really out of balance because there's not 7 phases here. So yeah, that would still be an 8-phase. It would just be a dumb 8-phase, whereas this is a 4. And that would still be better than this. And then you could go and take take 2 phases, because as far as I know, the IR35201, if I remember correctly, that only goes to like a 6+2 phase configuration. You can't do a 4+4 off of it. It's not that flexible. So you could do a 6+, so you could have a 4+2, because you could just not use 2 of your 6 available phases for vCore. Double the 4, get your 8, and then you would take your 2, double that again with some kind of doubler, or a 3598, which integrates the drivers, and then you could get your 12-phase. That would be one way to get the 12-phase that that Asrock is advertising here, and that's actually what they would have done if they actually used an international rectifier voltage controller, which they didn't. Which is just like, this is a new low as far as I'm concerned. Like, this is an all-time new low. Because I've never been, the lying about how many phases you have, that's just standard, okay? That's just been a thing with motherboard vendors for years and years and years. So at this point, I'm just like, okay, you're not really any worse than anybody else. But when you go and you say you're using an international rectifier voltage controller, and I find an intersil, really? Like, really? And it's not like there's anything on the, there's nothing on the back of the board. It's like, oh, they hid the international rectifier on the back of the board. No, they didn't, because there's nothing there. Because the board has to be cheap. Having a whole bunch of control circuitry on the back would not be cheap. There is a bunch of bypass capacitors on the back, but yeah, it's fake. It's super fake. Like, they are lying about which freaking voltage controller manufacturer they're using. Like, what the hell? Like, seriously, what the freaking hell is wrong with them? It's just like I don't know. I don't know what to tell you. It's just like, I'm lost for words. I am like, this is just straight up lying. Like, they're lying about the phase count already, but that's just like, it's like kind of, I think that there is kind of a lost cause at this point, because everybody does that. But Gigabyte was kind of pushing a new limit with removing the extra high side MOSFET, which is like, okay, see this has 8 high side MOSFETs. They're not actually running out of phase with each other. Well, they're running out of phase with each other in groups of 2. Which actually, I didn't go through the whole gate demonstration. So if we go across from like this phase, so these 2 are tied together, right? Those have their gates tied. There. So those gates are tied together. But if we go to the next phase over, you can see that's actually a separate phase there. But if we go from that MOSFET to this MOSFET, they're tied together again. And if we go to this one, they're separate. And if we go to this one, they're separate, because those are your phase divisions here. And I think, yeah, so those are separate. But those 2 over there, those are combined. Aren't they? Come on. Oh, wait, I might be measuring the wrong side. Oh, yeah, that's the gate lag. There's a resistor. Come on. No, this is not the bloody gate. That's the gate. Was right the first time. Freaking tripod getting in the way. Okay, come on. Those should be tight. Or are these oriented? Oh, no, that's the... Oh, oops. That makes sense. That's the low side MOSFET. That's why I'm not getting the measurement I want, idiot. Why is it not measuring the gates? Being in... Come on. There. That's what I wanted to see. So yeah, they have the two high-side MOSFETs up here, and then you have your two low-side MOSFETs, which, I mean, that already tells you, like, everything you need to, like, is that actually? Yeah, that is exactly what they're doing. Because that is a PK618, and that is a, I don't know what, but these two MOSFETs are the same. These two are different, so that's low, like, it's either low, low, and high, high. And actually, we can check which one of them is hooked to 12 volts. Oops, what did I press? Press hold. No. There. There. I think that's 12 volts. Let's check. Yeah, that's 12 volts. So yeah, that's the high side FET there. So yeah, those are your two high sides. There's your two chokes for them. There's your two low sides. Not a 8-phase. Also not an IR voltage controller. It's just, oh, and all of these are of course fake as well, because this doesn't support, like, you can't double on the output of the SoC VRM either. Like, you have a choice with this controller to build you can build anything from a 1+1 to a 4+3, but you can't put anything higher than that. And this is advertised as a 12-phase, which, you know, if you count the chokes, it looks like an 8+4. And they're advertising it as having IR, which is just like liars. Like scum and liars. To their credit, though, they aren't lying about that part. The Nichicon 12K black capacitors, also I accidentally went to the other webcam if you're wondering what was with that cardboard. Those 12K black capacitors, they actually have those. These are actually FP series Nichicon capacitors rated for 12,000 hours, but and the chokes may or may not be 45 amps. I don't know. You can't really get a data sheet for these because this is such a generic component that, like, the motherboard manufacturers can just ask for like a specific design to be made for them. But I'm still going to say that they could replace, every two of these chokes could just be replaced with one 60 amp choke. And I'd actually prefer that because that would probably be cheaper for the end user of this board. But hey, you know, Asrock, new lows. I guess Gigabyte has something to be happy about. They're not the worst liars on the block anymore because these guys don't know how to read their own freaking parts manufacturers. I wonder if Intersil would be annoyed that one of their I'd assume that, like, Asrock has a decent, like, a relation with Intersil, so I wonder if they'd be pissed off that they're getting advertised as being International Rectifier. Anyway, that's it for the video. Thank you for watching. Like, share, subscribe, leave a comment, questions or any suggestions down below. You know, and if you'd like to support what I do here with actually hardcore overclocking, I have a Patreon, a PayPal, and t-shirts. You can find a link to all of that down in the description below. Thank you, patrons, for funding my lovely new multimeter here, and for funding the purchase of this board of lies. Yeah, see, this is why Asrock's never gonna sample me. Actually, no, like, yeah, this is new. This is a new low. Like, really, this is a new low. I can't believe that, like, I couldn't believe my eyes when I pulled this board out of the packaging, and I was like, ooh, this is gonna have a 35201, and then I look right there, and I'm like, that doesn't look like a 35201. So, yeah, it just, like, I don't know, I don't think most reviewers would ever notice something like that, because quite frankly, like, yeah, but that's not an IR part. So that's not an International Rectifier VRM. I'm actually not sure there's anything from International Rectifier on this entire board. And there's a good chance that's the case, that this board is literally devoid of any International Rectifier parts. But hey, I'd love to be proven wrong. Asrock can totally go and point out the one chip from IR that's like buried somewhere in the not important section of the board. Well, not important to overclocking section of the board. We're free to do that. So, yeah, and I'd really appreciate if they'd go and update their website and tell everybody that this is a 4+2 and that that's an intersil. So, yeah, that's it for the video. For real this time. And goodbye.